Hello and welcome to our video on serial dilution. So one of the challenges of the lab was to find the relationship between the concentration of sugar in a solution and the solution's density. Well, how can we do that? Well, we have to obtain several different concentrations of sugar solution, and then find the density for each one, and then we can find the relation. Today we're going to be focusing on obtaining the different concentrations. We can obtain these concentrations using a method called serial dilution. It is a way of obtaining several solutions with known and different concentrations, all less than the original stock solution, and it is performed in an iterative way. We can do this with the help of the dilution formula. The dilution formula is M1 times V1 equals M2 times V2, where M1 is the initial concentration, V1 is the initial volume, M2 is the final concentration, and V2 is the final volume. In lab, we will know M1, V1, and V2. M1 is going to be the concentration either from our stock solution or our previously calculated concentration. V1 is going to be the amount we take from the previous solution. And V2 is going to be 25 milliliters because we are using 25 milliliter volumetric flasks. Since we know those variables, we can solve for the second concentration by using the equation M2 equals M1 times V1 over V2. And this is obtained by using algebra. We must first start with a stock solution. Here we can see Alex pipetting our stock solution into the 25 milliliter volumetric flask. She's going to pipette it until it reaches the 25 milliliter mark. When measuring volume, make sure to account for the meniscus. The meniscus is the U shape formed by the water due to surface tension when it sticks to the side of the walls. Always measure to the bottom of the meniscus. Here you can see the line is lined up with the bottom of the meniscus, meaning the volume is 25 milliliters. Here's a better view of a meniscus from a graduated cylinder. Here you can see Crimson measuring out 5 milliliters from our stock solution. We're going to pour this 5 milliliters into another volumetric flask, and it will be diluted to the 25 milliliter mark as well. From there we can calculate the concentration, and then we can keep doing this until we reach our 4 concentrations. Once you've serially diluted and obtained your solutions, you can start to weigh all of them, as I'm doing here. We are weighing them to obtain the density, and the equation for density is mass over volume. We know the mass because we're weighing it right now, and we've obtained the volume in previous steps. Here you can see the data table for all of our serial dilutions. We have a column for the solution indicating stock 1, 2, and 3. The concentration would be the which would be the M1 for each successive solution. Then we have the V1 and the V2. And to the side we have a sample calculation where M1 is 20%, V1 is 5 milliliters, our V2 is 25 milliliters, and we can use our dilution equation to calculate 4% to be our next concentration. Thank you for watching.